One way to describe the behavior of a function is to determine the intervals where the function is increasing and decreasing. Now, this is a pretty simple concept, but the mathematical definition can be a little bit challenging. So to understand these definitions, let's take a look at the picture of a function. Suppose that I have some sort of function just passing through quadrant 1 that looks something like this. Now, would you say that function is increasing or decreasing? Well, it sort of depends, right? Let's imagine this curve as terrain. Suppose that I'm walking along this terrain and I'm going this way. If I'm walking this way, then I'm going uphill, right? So that curve could be interpreted as increasing. However, if my friend is up here hanging out, walking on the same terrain and moving this way, then I could interpret that as decreasing, right? So it's going to be increasing or decreasing depending on the direction of motion. So what we're going to do is settle the matter and only read our graphs from left to right. If I read this from left to right, then that's going to be an increasing curve. So again, it's pretty easy visually to tell if something is increasing and decreasing as long as I read it left to right. But how do we state that with rigorous mathematical terms? Let's define intervals of increase and decrease. A function is increasing on an interval I if y sub 1 is less than y sub 2 whenever x sub 1 is less than x sub 2. Probably not the first thing that popped into your mind as you were thinking about increasing and decreasing. So let's break this down a little bit. Let's consider 2 points on our graph, the starting point on the left and the finishing point on the right. The first point here has x value x sub 1 and it has y value y sub 1. So that would be ordered pair x sub 1, y sub 1. Where our second point has x value x sub 2 and y value y sub 2. So that's the ordered pair x sub 2, y sub 2. So our definition says our function is increasing if the first y value that we encounter is lower than the second y value that we encounter. So notice our first y value here is lower than our second y value. But that only works provided we are moving left to right. So my x sub 1 less than x sub 2 indicates that we must read this graph from left to right, as we discussed. Okay, similarly, a function is decreasing on an interval if y sub 1 is greater than y sub 2 whenever x sub 1 is less than x sub 2. So again, my inequality for x is the same, so we're always reading left to right. But in this definition, if the first y value that I come to is bigger than the second y value, then it must be decreasing. So here's my first point, here's my second point. The y value of this first point is higher in elevation than the second point. And again, we're reading that left to right. So our function is decreasing. There's one other possibility. A function can be constant on an interval. If the y values stay level, all y values are equal whenever we read the graph from left to right. Now, as we learned previously, a function is a relation in which every x value has a unique y value. So to describe the intervals where a function is increasing and decreasing, we can do so in terms of the x values only, because each x value indicates a unique y value. So I'm going to be thinking about the y values to determine if the function is increasing in elevation or decreasing in elevation. But I'm going to quote it with the corresponding x values from left to right. So let's give this a try on example 4. Determine the intervals where the function is increasing, decreasing, or constant. And we're going to quote it with interval notation. So looking at our graph and reading it from left to right, clearly this part is increasing, right? It's going up as we read it from left to right. And this little branch is decreasing. because as we read it left to right, the elevation is getting smaller. And then this part, as we read it left to right, is increasing. So it's a trivial matter to figure out if something is increasing or decreasing. What's more challenging is to quote it appropriately. So where my function changes from increasing to decreasing, I'm going to use a little guideline here to relate it back to the x-axis. Here it changes decreasing to increasing, so I'm going to relate it back to the x-axis. So to quote the intervals of increase, I want to read that interval from left to right. So notice this little red line on the left here. We know our function is increasing here. I'm just going to quote the x values used on that portion of the graph up till my boundary line. So my leftmost x value here is negative infinity, and then we're going to work our way right up to this point, but we're not going to include it in our interval. So we're going to go from negative infinity to negative 1, but I'm going to use a parenthesis here as opposed to a bracket. The reason is because at x equals negative 1, this one little point right here, the function is neither increasing nor decreasing. It actually changes from increasing to decreasing. Okay, and then we have another interval of increase right over here, and I want to read the x values from left to right. So the leftmost x value here would be 1, and the rightmost x value is infinity. So we would say from 1 to infinity. Again, using a parenthesis with 1. You'll always have parentheses with intervals of increase or decrease. Now, I separated those two intervals with commas. Oftentimes, you'll also see this written negative infinity to negative 1 union 1 to infinity. You'll see a little U symbol in between, which represents union, and that unites your two sets together. However, MyMathLab uses a comma between the intervals, so that's what we'll do as well. Now, let's figure out where this function is decreasing. So our little green segment here, we figured out it was decreasing, and I want to figure out what x values correspond to that interval. So my leftmost x value here is negative 1, and my rightmost x value is 1. So it is decreasing from negative 1 to 1. Now, that looks an awful lot like an ordered pair, but it's not it's not x equals negative 1, y equals 1. It's from x equals negative 1 to x equals 1. The notation is just very similar. And because we don't have a stretch where this function is flat or constant, we can just answer this part none. There's no intervals where the function is constant. Okay, let's try that on the next one. Now, this is a broken graph. We call this a piecewise defined function because it's made of the piece of a line and a piece of a parabola, or this curve over here. Also notice I have an open point here and a solid point here. Those details will be really important as we consider our notation. So where is this function increasing? Where is it going up? Well, it's going up on this interval right here. Where is it decreasing? If we, again, moving left to right across our graph, this part is decreasing. Let me label this part as increasing. And then we've got a flat line up here, so this part of the graph is constant. So pretty easy to recognize those. Now, what I want to do is use these vertical guidelines to divide where my function changes from constant to increasing to decreasing. And then you can see I've got 3 intervals on the x-axis. This little interval, the small one here, and then this entire interval. So we want to know, where is the function increasing? The function is increasing in between those two lines right there. So the leftmost x value there is negative 1, and the rightmost x value there is 0. Remember, that's from x equals negative 1 to x equals 0. That is not an ordered pair. Where is the function decreasing? Well, it's decreasing on this interval. So from x equals 0, the rightmost value there is x equals infinity. That is, there is no rightmost x value. So we say it's decreasing on the interval from 0 to infinity. And then finally, where is this function constant? It's constant on this interval. That's from x equals negative infinity to x equals negative 1. Remember, all parentheses with intervals of increase and decrease.